So if we are given a graph, and this one is g of x, we're going to graph its inverse on the same grid. Notice here it does not say inverse function. Just says inverse, doesn't say inverse function. In part B, they're going to ask us if the inverse is a function or not. Okay? What I'm going to draw on our graph is I'm going to draw a dotted line for y equals x, so we can see that reflection. Now, reflecting over a diagonal line is a little bit difficult to see. You are allowed to cheat on your final exam and turn your page 45 degrees so it becomes a horizontal line. Then it's really easy to flip over. Okay? You just have to do it discreetly so no one sees you turning your page during the exam. And the other thing you're going to do is you're going to look at the points that you have. And again, the idea is just switch the x and the y. So, for example, here I have the point 3, 2. I'll label that in red. My new point is going to be 2, 3. Notice I just switched the x and the y. My next point, I have 1, 3. I now have 3, 1. Here I have -1, -1. When you switch those points, well, then you get -1, -1. That point stays the same. And finally, the point that we have here at -4, 4 becomes 4, -4. So first of all, we look at the points that we had both originally, move that one away, both originally and where they end up, and you can see that they're a direct reflection over that diagonal line. The other thing that I hope you notice is that this point that stayed the same was a point that was on the line to begin with. So another point that's going to stay the same is right here, even though it's not one that we labeled. Now you just have to connect the dots so that it is a reflection over, and you have your new image. Is this a function?
No, because some x values have more than one y value.
Right. So for part B, it is not a function. We can say it does not pass the vertical line test. And what that means is if you take any vertical line and you move that vertical line along, if that vertical line ever hits more than one point, and on the blue graph you can see right there it's hitting 2 points. Here I even have a place where it hits 3 points. Okay? A function, for every x value, there can only be one y value. So if it ever hits more than one y value, then it is not a function. So it does not pass the vertical line test. Therefore, it's not a function because an x value has more than one y value. State the domain and range of each. So again, for C, domain and range of my red one, domain and range of the blue one. For the red one, does it have a smallest x value? Yes, it does, at -4, less than or equal to x. Does it have a largest x value? Yes, it does, at 3. Or you could write this as -4 to 3. And for the range, does it have a smallest y value? -1. Does it have a largest y value? It goes up to 4. So we could write this as -1 and 4. Now sometimes you'll get an inverse question where they just give you the domain and range without a graph and say, now what are the domain and range of the inverse? Now remember that domain are your x values and range are your y values. And if an inverse, all it's doing, the key idea, is you're switching your x and your y values, then all that's going to happen, and you can see it in the graph, but we'll also see it from here, that the y values of our range become, switching the x and y, the x values of our domain. And the x values of our original graph become the y values of our inverse and look like that. So the key idea, again with inverses, the x and the y values get switched. And that has so many applications in so many different ways. We saw it in the example before, right? Right at the beginning there. Where we had this equation, and we said algebraically, that's what happens. We switch the x and the y, and then if you would solve for y, you could find the inverse function algebraically that way. And we did that for this question off to the side. Graphically, we see the same thing, which is the example we just did, where all we did was take the points and switch the x and the y. Then we could get the new graph. And we see that that's the same as flipping over the line y equals x, because that just switches your x's and your y's. And now we see with our domain and range the same thing, that if I'm just looking at my x values, it's going to change to my y values for my inverse. Yes? Well, this one didn't have an equation to begin with, right? The red graph, we were just given the graph, but we weren't given the equation. Oh, so this one is in function notation. So if we wanted to write this one, okay, it would almost be this. Almost be y equals g inverse of x. But I can't write that because that's a function notation, and g inverse of x means the inverse function. So there's nothing I can write in function notation for this because it's not a function. Usually that would be what you would write if it were a function, because that would be allowed. Okay, the questions you can do for this one are number 4 and 9.